Okay, so now we want to put into practice what we saw in the last lecture. So find the normal and tangent vectors to this surface. Okay, so this is of the form f of xyz is equal to 0. Here, f of xyz is x squared minus y squared minus z. And so the normal vector at the point 2, 1, 3 is going to be the gradient of f evaluated at 2, 1, 3. So this is the x derivative of f is 2x, so this is 2 times 2. The y derivative of f is minus 2y, so this is minus 2 times 1, and the z derivative is just minus 1. And so this is equal to 4 minus 2 minus 1. And that is a normal vector, so the equation for the plane then is going to be 4 times x minus 2 times y minus 1 times z minus 3 is equal to 0. Okay, so now we want to find, so we have the normal vector. Now we want to find two tangent vectors. So we're going to use the plane to find two tangent vectors. So let's find 2 points on the plane. So we know, of course, the point 2, 1, 3 lies on this plane. So now let's look for a point where the x and y coordinates are equal to 0. If the x and y coordinates are equal to 0, then the equation for the plane becomes minus 8 plus 2 plus 3 minus z is equal to 0. And so this says that z has to be equal to minus 8 plus 6, so that's minus 2. And then let's assume there's one where let's say the y and z coordinates are equal to 0. If the y and z coordinates, I'll just come down here and do some scratch work. If the y and z coordinates are equal to 0, we have 4 times x minus 2 plus 2 plus 3 is equal to 0. So this says that 4x, well, not 48. This says that 4x is equal to 8 minus 6, which is equal to 2, or x is equal to 1/2. Okay. So then we could say V1, if this is P naught, this point is Q1, and this point is Q2, we could say V1 is equal to 0 minus 2, 0 minus 1, minus 2 minus 3, minus 5. And then we could say V2 is, let's see, so 1/2 minus 2. So 2 minus 1/2 would be 3/2. So this is minus 3/2. Oops. And then 0 minus 1 is minus 1, and 0 minus 3 is minus 3. Okay, so these are two tangent vectors, and then any other tangent vector is just a linear combination of these two vectors. In the next video, we will do the problem on the bottom, but there's a typo that I will fix in the next video.